All right, here's another type of problem. It's very similar, but very subtly different. Starts out with 100 kilograms per hour feed, 30% acetic acid, 70% water, countercurrent liquid-liquid extraction. The solvent is at a flow rate of 200 kilograms per hour again. But now the question is, if there are two stages, what will the compositions and flow rates of the products be? So last time we had a 5% specification. Because I've now specified that there are two stages, I've removed that specification to keep the degrees of freedom appropriately specified. So let's draw a process flow diagram. Only two stages. Feed and solvent are known, and countercurrent. Right, so specifying everything, same 100 kilograms per hour, 30% acetic acid, 70% water, and 200 kilograms per hour of solvent. This is a predict type problem because S and N are specified, but the outlet composition is not. That's what we want to solve for. So predict compositions. All right, so let's go through the solution procedure and see how it changes. So let's just try and do everything the same as what we used to do, and we'll see where we get stuck. So solvent is still in the same place graphically. The feed is still in the same place graphically. We can connect them with a mixing line, and we can calculate where the mixing point is supposed to be. So 200 kilograms per hour divided by 300 means that I have 67% vinyl acetate again. So my mixing point is there. However, this time I don't know where either E1 or Rn is. So before, when I connected Rn to the mixing point and beyond to find what E1 is, I can't do that anymore. So now this is where I have to do a guess and check type procedure. So I have to guess a value of Rn. I have to guess the location of Rn, would be more correct to say, and then figure out where my E1 is after that. So I knew last time it took me, I had 4 stages and I had to get down to 5%. I only have 2 stages now, which is just thinking about what the answer is probably going to be. I want to make an educated first guess. If I guess something that is less than 5%, that would be a poor guess because I have less stages. So just in general, as I have fewer stages, I expect the quality of my separation to decrease. So I won't get as pure of a product. So I am going to guess, what do I want to guess? Let's guess 10%. Probably not correct, but that's okay. So let's make that our guess. And this is X acetic acid in the last raffinate stream is 10%. Now that I have a guess for where Rn is, I can connect it to the mixing line and beyond. And it happens that it's a kind of a straight line straight across, tracking on 10% acetic acid. Then that will tell me what my E1 point ought to be. All right, so E1 is there, and I can do this all graphically again. So now that I know where F and E1 are, I can connect them with a mixing line, and I'm going to want to extend this much beyond the space of the diagram and do the same thing for Rn to S. Moved it at the last second. Let's see if I can get a more precise. That looks pretty good. And notice that when you're drawing this delta point out here, it's very sensitive to where your points are drawing through. So this is, again, a situation where some degree of error is expected and acceptable. All right, so now I've got a delta point. I can now go E1 to R1. So I'm going to say that R1 and E1 must be in equilibrium. So I know where E1 is. If I wanted to, I could write down what the compositions are, but I'll skip that part for now until I know that my answer is correct. And I'll draw a tie line across from E1 to R1. And then draw a line from R1 to delta. And where it crosses the equilibrium line is my E2. All right, now I'm going to draw a tie line from E2 over to the other side. And what I want to happen is I want it to land directly on my guessed value of Rn. If it doesn't land directly on that guessed value, then that means that my guessed value is wrong. And I have to go through and try again. So drawing over, it looks like I've overshot it a little bit. So this means that my guessed value, again, is I went too far the other way. So in other words, with 2 stages and the Rn that I chose, I didn't get good agreement. So if I were going to go through and do this problem again, I'd probably try again and I'd guess something a little bit less. So somewhere between 5 and 10% should do the job. I'm not going to show you how to go and do that again. The procedure here, the good news is that a guess and check type problem typically takes a long time because of all the calculations you have to do in the middle. When you're doing it graphically and you can sketch lines fairly quickly, you save a little bit of time. But still, just in the interest of time, I'm not going to show you how to go through and do another guess. I'm going to call this video completed, and I would say that my actual value of X acetic acid in the last raffinate stream is probably greater than 0.05, but less than 0.10. And then I guess to completely complete the question, I would have to first get the correct answer for where my raffinate is. I would have to get the other 2 compositions from this point, all 3 compositions of E1, and then solve the overall material balance to find what my flow rates are. So again, this is a predict type problem. You must guess and check, but it doesn't seem too bad. One more problem to solve for today.